Hi, Dan. I'm not sure if you're talking, but I can't hear you.
Okay, is that working?
It works now.
Okay, yeah.
All
So,
right.
so I was saying, I wasn't expecting this meeting to be a one-on-one. I mean, let me ping in the Discord chat. But if we don't get quorum, we can either call it, or you're not gonna have a conversation. But maybe if you wanna have a conversation, maybe we can just hop on another call.
Sure.
But let me check if other people are coming.
Okay.
But so I'll give it a few minutes. I'll put up what I wanted to talk about today, and there we have a few people showing up. Okay. So we have a few people showing up, but this is all Intel side. Like if we don't, because what I wanted to talk about today was some of the coordination on. Let me see if I can go back to that slide. Was really to talk about some of the interactions on what we do on shutdown, graceful and ungraceful shutdown. Like um, uh, if we need more context to be set with KVM around. That was Robbie too. Uh, More context with KVM to be set around, hey, whenever you go to tear down trusted MMIO, you need to do it. You need to make sure that the device is in the unlock state first, so that the device knows to start rejecting things. Basically, so the device knows it should start rejecting T equals 0 traffic. Uh, and so I know TDX has that requirement to do that ordering because of specific windows of if you unmap things, but the device is still in the run state, it could conceivably be open to peer-to-peer traffic that we don't want. Um, I think I think other vendors have a different solution to that problem, so it may not have the same ordering constraints as what TDX is enforcing, but maybe they do. So I basically wanted to have an open discussion around that and whether we needed to talk to the KVM people about it. Um, but now that Robbie's here, yeah, we have at least somebody else we could ask the question about. So maybe let's just maybe we can have that conversation. Um, uh, but the RFC last time we talked about this, RFC v2 went out. This was to get some um, collaboration on the PCI interactions, and the goal was, okay, let's get ready. let's get on the same page as vendors, and so that we can go to Bjorn and say, okay, Bjorn, it's time for you to make a decision about this look like the right direction. So I was fully planning on doing a non-IRC posting to get to that point and make the case and show, hey, look, we have multiple vendors showing up to do this. But Bjorn's already he already acted the integration that we've already proposed, and so he acted this approach, which to me signals that it strikes the right balance of a PCI integration versus not, and we can just basically just go. Like I'm not going to argue past yes if he's already willing to accept that level of integration. So that's good news from my perspective. I and the comments coming in from Alexi on there have been just good feedback and normal review, but nothing along the lines that we fundamentally disagree and need to go back to the drawing board. So nobody's here to counter my statement, but at least from my perspective, things are looking pretty good. Oh, I also see another name you joined. I don't recognize the name. Rob, do you want to quickly introduce yourself? Maybe.
Here's my colleague from NVIDIA, Dan.
Oh, okay.
Yep.
Hi there. Yeah, sorry, switching to the right thing. I work with Gobi. Gobi's the main pick on this, but yeah, I work at NVIDIA as well on the confidential computing architecture over here as well.
Okay, cool. Welcome. Yeah. I'll give you the quick spiel. This is an open source call. It's being recorded, so we're all talking here in terms of things that we would say on the Linux mailing list, just to level set that playground of where we're at. And who is HWU13? Nobody recognize that? Yeah.
I think it's Hao. Wu
Oh,
Hao.
how? Oh, okay. I know him. Okay, good. Okay, yeah. So where I was at was saying that pleasantly surprised to be in the position of Bjorn kind of hacking things. I also think my personal read of that is also that this stuff is complicated enough. Like, not that he's relinquishing review control over this thing, but in terms of like the details, I feel like I think he's saying, you guys tell me what you need from PCI integration, but otherwise, like, as long as everything else is self-contained, I'll trust you. I don't want to read too much into that, but that's what I'm operating under the assumption that I think that we have some runway here to write our own destiny. So that's good. And so then to me that means, okay, next step is clean that up and start talking about these KVM interactions, and especially in places where we think we need some new common infrastructure, new callbacks that all TSM, PCI kind of TSM implementations would need, and start arm wrestling that next level. That was always going to be like the next level of complexity and difficulty. So I think that's going to be a harder discussion than this initial PCI phase, but it's kind of good to see the PCI phase coming to a resolution. The one thing that I was hoping Lexi would be here was to talk about, we have this interface going from the PCI core back to the low-level TSM driver saying, execute this operation. He said that didn't really work well for being able to generically return things back to the PCI core in terms for like any sysfs attributes that the TSM would want to publish. My expectation and recommendation there is, if it's a TSM specific attribute, then there's nothing stopping that that TSM implementation from shipping its own sysfs attributes. Like we don't need to teach the PCI core about everybody's TSM attribute. But if there's some common thing that we want all PCI devices attached to a TSM to export, then we would just put that as part of the PCI dev TSM state. So I think we have a path to let people do custom attributes and have them be namespaced by the vendor, by the platform, and we have room to do some PCI core common things. So basically, nothing scary so far on the RFC feedback is my read. If anybody else has any feedback, feel free to raise it. But that's what I'm operating from. But this graceful versus forceful shutdown case is where we were going to ask if other TSM implementations had this requirement of needing to of having any dependencies on making sure that the device is in the unlocked state before you start unmapping DMA, start unmapping MMIO. And yeah, that was the question, right?
Yeah. For now, I actually just take some look for MD solutions, and I don't think they need to unlock the devices before KVM NPT unmapping. Yeah, I don't think they have these restrictions.
So, what the question I had was like whether that could be supported in an ungraceful way, like if basically if you got the sequencing wrong, it's not unsafe, but it may put the device into an error state. But that for the graceful case, we might need to, or you think they can, or you think it's probably the case that there's a graceful shutdown flow that doesn't require any ordering of those events.
I don't say I don't. I think they need some ordering, but like they are they could naturally good to the kernel the destruction sequence. That is when the process is force killed, the kernel would firstly destroy the memory mapping and then close all the files. And their sequence, I think their sequence could fit for this sequence of kernel destruction. Yeah. That is to say, they could firstly unmap the KVM page tables, then they unlock the device and remove the device.
So I recall that the reason the sequencing is there is because of this concern of you can use the IDE default stream to do peer-to-peer traffic, like unlike the bind P2P stream TDIS command. If you don't need to use that if you're using the default stream, and that when we go to remove a device is private, we basically go to unmap private MMIO, that we don't want anything that was accessing MMIO space thinking that it was private, or that the device thinking that it can return private information from private MMIO after we've decided that we want to unmap it. And so you're saying that you think that when the unmap operation happens, There's no gap. There's no gap where peer-to-peer cycles can get in to read private data out of MIO, where we need to unlock it first so that we know that the device knows that it should shut down any private access.
No. My point is that because for MDs they don't share SCPT with the LMMU page table. That means they have independent LMMU page table. So when KVM want to delete its page table, it could just do it. The LMS side is not infected.
Okay, that starts to make sense. Robbie, are you following the discussion? Do you happen to know how CoveIO is handling private MIO? Is it similar to this shared EPT case that we have on TDX, or is it more independent,
Yeah,
more like
it is a common.
RMP?
No, it's a common second level paging structure managed by the TSM, which will be used on the RIS5 IMMU side as well.
Okay, so it's a similar shared second
Correct.
level.
Correct.
Okay.
Correct.
So conceptually, even if we didn't need this, ordering constraint for AMD, but we did need it for Intel. If we built it, it would probably also be of use or importance to CoveIO.
Sorry, can you tell me what the ordering constraint is again?
The ordering constraint is if we ask the module to unmap MMIO, but the device is still in the run state, the module says no. He says you got the order wrong. You have to unlock the device, then you can unmap.
I see. Okay.
Um,
Yeah, that would work for CoveIO as well.
Okay. The difficulty though is that at the places where KVM would naturally just start unmapping things, it doesn't know anything about that those mappings were for devices. Like it basically it puts a constraint on unmapping that it causes KVM to need enlightenment about devices that it never needed to have before. Because before you could just unmap things in any order. Well, and there was no concept of devices being in any kind of private state. But this requirement basically means that we either need to have a callback or we need to have some context that says, hey, by the way, KVM, before you touch this mapping and tear it down, make sure you unlock these are the devices that are impacted by that mapping, and you need to unlock them.
But KVM would know that the device has been mapped to a different kind of container, right? In this case, a confidential VM. So
When we say KVM, I think the kernel knows about it, and like some like VFIO probably knows about it. And the TSM driver knows about it, but KVM just is like, oh, you told me to map, I mapped. You told me I'm mapping, I unmap. But it doesn't know that the what that mapping was used for. Like we will, but we are so. But it's interesting because there's another conversation going on the list around pre-faulting private memory pages. So basically, so that we can, before we do anything, like while we're setting up the TD, we tell it we basically pre-fault in the private memory so that we have that handle so we can set up the second level mapping, like do all the second level work. That sounds like something that CoveIO would need as well. And so when I heard about this issue that Yulun brought up, my thinking was that if we're pre-allocating page tables and things for TSMs that need this shared second level architecture, maybe that's also the place where we register that by the way, for these private mappings, they need a we need to associate this like device context with them so that can be unwound when the mapping gets torn down.
Yeah.
Okay, but that's good in the sense that that. At least it's not like one architecture needs it, one architecture doesn't. It's more like two architectures need it, and one doesn't. And so that's I think that's a much easier conversation with KVM folks to be like even if you grumble at it, if you grumble at adding it for one vendor, don't worry, you get the benefit of solving the problem for multiple vendors at once, and so that makes it easier. Okay, so that's good feedback. I'll take a note on that. The other one was we were having a conversation about this is kind of in the similar vein of like what do we need to make sure to have in place for these different graceful flows was what happens if somebody does a PFFLR, functional reset on the physical function, and the expectation so on the VMM side, like we can definitely build a facility into the Linux way that you issue PFFLR to say, oh hey, this device is connected to a TD, do all this extra graceful stuff before you actually issue the PFFLR. So that's a nice thing we get by being part of the PCI core. We can intercept that and do the graceful work. The problem is most kernels are built to allow config write access from user space. You have to be root, but root can go around and go straight to the capability and issue the PFFLR. And so the question is, what should the kernel behavior be around that event, or basically what do we do? Because we're basically going to have a whole bunch of software context that thinks that any VFs from that PF are still mapped and running, and so I'm sure the driver and the guest is going to be really upset and things are going to start failing. But I think the concern is more around how do we clean up? Because if we send a TDIS message, like if we do the normal cleanup, the expectation like you send a TDIS message to the device, say stop interface. But if the interface is actually gone, probably that stop interface request is going to be returned with like I don't know what VF you're talking about. There are no more VFs because of PFFLR happened. And so I think that leaves the security module, the TSM's state in an undefined state, because you can say stop interface, and all you know is that the stop interface failed. You don't know that whether it's okay to clean up or not, or whether that interface might come back. And I think how your suggestion was just leak all that context and wait until somebody tries to use it again, and then when we try to use it again, we know that the VF is back, and we can start to say, oh hey, there's old context there that we need to clean up. Was that the proposal, How?
I would have thought that because the host can always do that PFFLR at any point, that's sort of the equivalent of a denial of service. And the TDIs that have been assigned to, or VFs that have been assigned to VMs that have an active context should in that particular scenario, per the DSM enforcement on the device, switch into the error state, right? So you, as a host, when you now come around, and first of all, that protects the secrets on the device. Second, when you come around and reassign the device either to ordinary VM or a confidential VM, you would have to reset the state forcefully, right, as from a host perspective. So the host probably doesn't want to do a denial of service on itself unless it's buggy. So
Right.
only a malicious entity does this surprise PFFLR. And in that case, as long as the DSM enforces the interfaces go into error state, you maintain confidentiality, and service availability is anyway a prerogative of the host.
Correct. Yeah, I think the concern is like I think we're not. Yeah, we're not. I don't think there's no worry about lots of confidentiality or that, and the interfaces should go into error state. But the question is like how do we clean up any context that might be left over in the TSM? because it's not like there's an interrupt telling it that the FLR happened. Like and the TSM can't trust that that when we tell it, hey, there was a PFFLR, so you can get rid of that context.
Right, but the TSM state is a secondary state of the host, right? So the host that had assigned that any VFs in that situation to confidential VM will have some leftover state in the TSM, and it's the host responsible. It's not usable state though. The host has to come in and basically do a shutdown on that VM, because bad things are going to happen on that VM anyway when this kind of a situation happens, right? It's not like you're
Right.
going to resume from that situation.
That's like so basically your expectation is that
That VM will have to be toned down.
a surprise PFLR. Yeah, we probably just need to shoot the VM.
Correct. The VM will have to be toned down, and as part of reclamation of that VM assets, the host will have to go in and reclaim all the memory and convert things back, etc. So as part of that, you'll probably have to do a bunch of unmaps and cleanup anyway. It's sort of equivalent to a non-graceful teardown of a VM.
Can there be cases where the VM issues the PFFLR when it sees a TDA in error state?
Where
No,
the TD
VM should never be able to issue a PFFLR, right?
No, it can if you expose a PFFLR capability to the VM. In the case
Right,
of TDA pass-through mode.
Right, but in that case, the VM is basically acting as on behalf of the host.
Correct, for the predicate device, yes.
Yeah, that's fine. I sort of consider, and in this case, you're not talking about a confidential VM, right? You're talking about an ordinary VM?
No, CVM, right? It could be confidential VM.
Okay, sure. Yeah, but it's sort of like acting as an extension of the host, right? So
Correct.
same kind of policy applies, right? That it's a confidential VM, but it was passed through a device with full control. So it essentially is even though it's running as a confidential VM, it's acting as a host for that device to the other confidential VMs.
Are you saying Gobi like having a generic facility to do error recovery where one of the error recovery options that the guest driver might choose to do is escalate to, it's like, I know that we're doing basically whole device assignment into the TD, into the CVM, and I know my device is in a state where the only thing that's going to recover it is PFFLR.
Exactly. Yes.
But I'm assuming that we wouldn't want to give the guest we wouldn't just like map the config register and let the guest just touch it directly. It feels like that would be something we want to have a GHCI, like basically a guest interface to say, hey host, please do what you need to do to PFFLR this, restore IDE, and basically do the whole lot. Because we want like the reason we have PCI core integration with the TSM is so that we could conceivably do reset management for the PCI core. But like from the guest side, you basically want to invoke host side reset flow and recovery.
Sure, there are two options, right? One, you can expose any config space to the tenant, and the guest CVM could go trigger the FLR on its own. Or yeah, you can have a guest call into a host to trigger it. But from what you're saying, Dan, I think the latter is the option, right? Yeah.
Well, I guess it doesn't matter because we could just even if we gave the CVM the config register, we could trap it and do the full managed host side flow. Yeah.
Okay, but is that the expectation here? I think that is right.
Well, I mean, like I guess that's what I would say. Like if the TSM is like, yeah, if we're going to expose PFFLR to the guest, that part of exposing that would just be like, yeah, we probably should make that a VMM managed flow and try to reconnect and rebind the device so you can reaccept it.
Okay.
So actually, I have question is how the TD can detect the errors and decide what to do. So my understanding is that so from TD point of view, we see something wrong, it may try to, for example, unbind and rebind the device first. If it doesn't work, it may try VFFLR. So if VFFLR doesn't work, it may ask, for example, the admin to do the PFFLR. Right.
Correct. So we're talking about a full device pass-through where assigning the entire PF to a tenant or the CVM. So yes, you can, in the case of error, I'm sorry, there's a fire alarm here, but in the case of error, you could try to unbind and rebind. But if things is still not recovering, you can do the full PFFLR. Yes.
Yeah.
And detecting error condition is something that we have to talk about, Dan. That's no standard defined way for a TD to detect whether TD is going to arrested or not.
But I'm assuming that we at the worst case we always have that we always have timeout. Like guest driver timeout is like yeah, I might need to escalate to some other kind of reset recovery because especially because like that's the nicest just because anything else that like uses AAR notifications like the AR sorry about that or but the AR notifications like basically would require teaching the now I'm gonna have noises here too teaching the PCI core how to do secure device recovery flow, and I really feel like we don't want the guest PCI core to do that. Like, but well, actually, right now the if you look at the KVM or the QEMU AR response, it just says abort TD. It kills again. Like if any AR happens with an assigned device today, QEMU just kills the VM.
Sure, but a TDA can go into error state for many different reasons, right? Even outside of the AER, right?
Yeah. Yeah, no, but so as long as the error state is like we basically would say like that it's the driver's job to figure out that you went to error state and start triggering reset recovery actions, and we just need to think about what happens if a driver wants to escalate to PFFLR. How do we because I'm assuming like you want PFFLR and your expectation is that when that completes, the device is already bound again, or
the TDA is bound and unlocked state.
Rebound unlocked. That's the only thing that makes me think that you'd want it to be an explicit interface versus just trying to emulate it by trapping the PFFLR request, because that's a pretty large flow of rerunning SPDM, everything like I was gonna
rerunning ID, right? Not the full SPDM.
Not the full. Oh, because the SPDM session should still be there.
Correct. SPDM is still there. Yes, it's not cleared up during PFFLR.
Okay. I mean, but we still need to do the IDE key establishment flow again.
Yes.
Yep. But all I'm saying is that seems like a lot of work to hide behind a single config cycle right in the guess. Like it might want it to be a request and response kind of ABI, but that's a detail. I think we can figure that out. Maybe it's okay, and we already have pretty long emulation flows. I don't maybe how are you, Loon? Do you think that would be a problem to trigger IDE reestablishment rebind on a guest triggered PFFLR? we still have. How or Yulin?
Sorry, Dan, can you repeat the question?
Question was so Gobi was talking about the expectation that if we have this PFFLR recovery flow, that his expectation would be that after triggering that, when that returns, that the device is basically back into the unlocked state, and ready to bound again, bound and ready for acceptance again. Basically, going from this, if we go from bound and they trigger an error, and the guest side driver says PFFLR, that we should get the device back into the bound state so that it can be reaccepted.
Yeah, I
And the
think
que-
it should be okay. So if it's only a PF device without SRA, so I mean SRA is disabled. But my concern is about a PF with SRA enabled. So for example, you're using a VF and you request the PFFR, it will impact other
Oh yeah.
waves, right?
Oh,
So if
so
you want just pass through a PF and the SRA is disabled, actually it should be fine to reestablish everything, including ID, SPD ID, and also make the TDI in bind state.
sure, whoever wants the PF function, I mean, has to guarantee the availability, right? So
Yeah, it would probably be the VMM's responsibility to be like, yeah, I'm not going to expose PF, like a cooperative VMM that's giving the guest a PFFLR is also not going to expose, basically let one guest hurt another guest, and also the denial of service is always within scope. So like even if a VMM messed up and gave VFs to one TD and gave PFFLR capability to another, and the other one used it, that's allowed per TDIS. But we would probably make sure from the VMM side never to do that. But I guess it raises a point like that we can get as fancy as we want with the kernel community, because I'm assuming that like if we did the PFFLR from the VMM side and we had a bunch of VFs that I don't know if we could gracefully convert all those VFs through the error state and back into the bind state. Probably could, but that'll be a TBD thing.
I think that's going to be catastrophic, right? Dan, if you ship PFFLR when VFs are active, VFFLR is a different case altogether, right? That's affecting only a single TDI.
Yeah. No, but I'm saying like that we're basically we're going to build a flow where the guests can trigger PFFLR, and we had to figure out what we do when there are multiple VFs assigned. Do we make the same guarantee, like you're saying we should make sure that for the full device assigned TDI that thing comes back into the guest already bound. Do we make the same guarantee for VFs
When they do VFFLR.
when they do VFFLR?
Yeah.
Okay, so basically, if somebody, so that case Hal was talking about of somebody trying to do PFFLR with multiple VFs, we would just say no, or fail it, basically make you escalate to some other reset. See what I'm saying? Like if either we need to handle recovery VFs and rebind them, after, or we need to say, or we need to prevent PFFLR from going forward, or turn it into the catastrophic event, which is tear down everything.
Yeah, I agree with that. So PFFLR is going to be catastrophic, going to tear down everything. So, but the VFFLR, it should be recoverable.
But PFFLR should be also be recoverable if it's single device.
Single device. Yeah, correct.
Okay. I mean, that sounds reasonable to me. So I don't put you on the spot, Ravi, but I think, but I might maybe it's a heads up that I might respond to this pre-allocate thread on the mailing list because Paolo was having some concerns like, should we do this, should we not? Maybe just make this TDX specific because nobody else needs this. But right now their vision is very scoped to like SNP TDX. They're not really thinking about the RISC-V thing and the ARM thing. And so I kind of want to let them know like, hey, don't put this thing in the TDX corner. This is a common architecture need for anybody that does this second level shared page table thing, which I think is ARM too, but I don't know. But it's good to get it's nice that RISC-V is there too.
Yeah.
Yeah, because really that like I think SNP and TX we're all the same boat, like trying to educate and just talk through the different needs, the KVM needs with Sean and Paolo, and I don't envy them like having to reconcile all these different architectures coming in, but when we can show them that things have common and reuse, like I think that makes they can sleep a little easier that night.
Yeah.
Okay. I got a lot out of this conversation today. Answered a lot of questions I had. We don't have to basically. I want to open it up for any other topics you want to talk about now, but otherwise, I think I kind of gotten what I wanted to get out of today's discussion. Well, and especially without AMD folks being here. But opening it up for open questions before we wrap it up.
And none from me. I just need to catch up on your recent RFC.
Okay, no worries. Yeah, I mean, to me, I was because I had been planning to look at the thread and have some questions about it for any kind of feedback items before this meeting, and I was really surprised that like the first message I get from Bjorn was ready, like thumbs up. I'm like, oh, that was easy. so now it's on to the next thing. But yeah, no, but it's not too late. Yeah, and we're still going back and forth with Alexi about some details. So yeah, it's not too late to jump in and make sure it's heading in a direction that's going to be usable for what you see on the Cove side.
Yep. Sounds good.
Hi,
Yeah.
Joe.
Yeah.
One more thing is, do we care about device hot unplug? Because I see we listed graceful and forceful shutdown here, but probably it takes almost the same flow generically, but device hot unplug is quite a different flow.
Yeah, like are you talking about like physical hot unplug on the host side that we can't that we can't prevent? Or are you talking about guest emulated unplug?
Yeah, it's for device hot unplug the TDI from the.
Oh, how to plug TDI from the device.
That results in fun whole SPDM teardown too, right?
Well, I mean, but I think we're only talking about removing the device from the TD, which I think we can say we can just say no to, right? Like, I mean, no. for simplicity, say again, you can't unplug devices like you have to do. Basically, how is what? Why do we need to support that, or can we? Is that something that we can add support for later? In the sense that we just say, yeah, unplugging devices, surprise unplugging devices from TDs is not supported.
Oh, I'm not sure if this is useful use case for customers to, you can hot plug a TDI or hot unplug a TDI. And another consideration is that, for example, if we want to handle the PFFR gracefully, so maybe we need hot unplug support. For example, as spec says, if we do the PFFR, the SRV is gone, right? So if we want to handle PFR gracefully, we may need to hot unplug the VFs first and do the PFFR and enable SRV and reattach those devices to the TDs.
I mean, I think there's two cases. I mean there's there's the PFFLR that we can't intercept, and then that one that will be a possibility in probably a lot of kernels. But I think it's okay for us to say that that is a catastrophic event, and you're going to lose TDs. Basically, we're not going to try to recover from that. And then there's a case of, okay, so now we require that where we don't want to tear down TDs when this event happens. What do we support? And I think we have the option to say that I mean, like to manage it through, like the only devices you could ever kind of hot remove and re-add are ones where you support PFFLR anyway, because that's effectively a remove and re-add event anyway. But if you wanted to, and yeah, I mean, so I think there's room to say that hotplug is always going to be a managed operation. Like it's never going to be the case where you just write a like I think today in QEMU, like a guest can trigger a device to be removed. I think what we're saying is for confidential guests, we'd probably remove that capability and force them to go through a new managed flow.
But there are some cases that it is not the guest that initiates the hot unplug. It is that the host removes the device, and then guest gets a notification that the virtual device is removed, and it would need some hot unplug process.
Yeah, I'm trying to think of the cases where we basically where we support that, but it's basically it's not an attack. Like certainly like a malicious or broken VMM can start removing things from the guest without telling the guest.
Yeah.
But I think for a non-malicious host or a non-broken host, it would coordinate that event with the guest somehow. That but so I guess you're saying like that we need to build some kind of notification interface to warn the guest that we're going to take the device through so basically warning guests about devices being unlocked without their knowledge.
I mean that it is not that the guest is unlocked. Maybe the guest is still in locked state, but it is removed by the host. Then the host driver doesn't support this device anymore. And then in this case, guest would get a notification that the device is no longer supported, and the guest would need to do some hot plug passively to do this hot unplug flow. And in this hot unplug flow, guest would need to do the same as the normal hot unplug flow, like it would unlock the device first, and then clean up all the resources.
Yeah, I guess I need need to see what interfaces you're talking about for how the hot plug is notified, and like where, and like if that's using kind of existing QEMU, KVM hot plug notifications, or if we're talking about building new ones.
I think there is existing a mechanism in legacy VMs that if the host triggers a remove of the PCI device, then the VFL driver would trying to be removed, and then the VFL driver would send a notification to QEMU to say that the device is trying to be removed. Then QEMU would start the virtual device hot unplug process that would interact with the TD, interact with guest, and the guest would do some cleanup work. Yeah, it would like hot unplug the remove the virtual devices from guest context. Yeah.
So you kind of more concerned with the with VFI, with the like basically with the TSM work, the unwind kind of cleanup work that that VFIO doesn't know about normally for the hot unplug flow. Is that the concern? Like basically the too much that the VFIO device removal event is not aware of what needs to be done on the TSM side?
I think when the hot unplug when QEMU started the hot unplug flow, the TSM would have some way to know the device would be unlocked and removed. Yeah.
Yeah. That's my expectation, or at least that's why I'm not too worried about the hot plug flow. That I think we might have the hooks to handle it, but yeah, we this might be a case where we need to actually have the patches in front of us. It's hard to talk about it with no pictures and no code.
Yeah. Actually, our I mean that with this flow, we actually need to support the hot plug and hot unplug in interfaces, even if no customer explicitly asks for this, because we need to handle this emergency case.
Oh, I see what you're saying. Yeah,
Yeah.
That might be true. But yeah, I want to see the patches first to see how hard it would be to enable the hot plug flow, and whether we need to figure out, yeah, that needs to be part of that. That's a piece of QEMU that we can't turn off, or it's something in QEMU that we have to enable the hot plug flow. I think that's kind of that's an open question at this point. But yeah, I'll take some notes. Yeah, and yeah, feel free to bring up the question on the mailing list. But otherwise, yeah, I guess we will see you at the next one. Unless any other final questions or opens.
Dan, we talked about after the PFF flood from the guest, we talked about TD as an unlock state to the guest, right? So how can do we have the APIs defined for a TDI in the guest to be transition from unlock to lock to run? Who will be doing it from the guest side?
I think what we're saying is like that we might, it might be the case where the unlock to locked transition is basically an implicit guarantee of the VMM or the TSM that the intent is at the beginning of time the VMM sets up IDE and assigns TDIs to the TD and puts them in the lock state, and then if any kind of error happens, the error recovery flow, like if you do PFFLR or some other communication, like is to reestablish IDE and relock the device. So it shouldn't be the case that the TD is going to need a TD locking, explicitly TD locking API. That's basically it's either in the error state and it's either locked and running, or it's either locked and available, or you have to trigger a reset to get it into the lock state again.
What's the need for TSM to implicitly move from unlock to lock state?
That's the thing, is that we probably don't need a way to do it explicitly. It'll be done implicitly on error recovery or when it sees it.
But so assuming that there's no configuration that needs to be done by the tenant before moving the device or TDI to lock state.
Oh, I see. Oh no, I see what you're saying. No, like yeah, we do want to support the bound but not locked state and have it be a runtime transition.
Yeah, correct. So one typical example is configuration. For the non-T memory range could be configurable, right? If you want to carve out a memory from the VDMM, a video memory to say this is a non-T memory, it could be a configuration that can be done before locking the device. That's one option, one use case. The other use case from the GPU side is you may not have all the software loaded up to handle the TD state machines. That needs to go from the PF driver. And I guess a full device pass through the PF driver is owned by the tenant. So the tenant has to load the software required for TD handling and then do the state transitions.
Yeah. Expectation is that we would have like a shared to private, like similar to we have a flow for shared to private conversion for memory. We'd have a shared to private conversion flow for devices as well.
Yeah. So our GPUs cannot work with lock state. It needs to do some configuration before lock state.
Yeah, and that's not just a single vendor requirement. That's a general error handling requirement. That's the way I'm mapping it.
Sure, something to keep in mind. Yep.
Yeah. It's always good to keep that in mind. Oh, but I got a kiddo walking in, and we've kind of reached the top of the hour. But yeah. yeah, let's circle back at the next one, and we'll be
All right,
yeah,
see you then.
good to go. We'll see you guys later. Okay,
See you. Bye.
see you. Bye.